So for this question, it said air is pumped into a spherical balloon. So you know that this is a spherical balloon. You are pumped inside the air with the rate of 250 cm cube per second. So from there, when your rate is increasing, dV dt will be positive. So we write down the information, identify your variables, and your shape of the questions. When the radius of the balloon is 15 cm, so for the question A, calculate the rate of the radius changing. So to find dr dt, we apply chain rule, will be dr dv times dv dt. So therefore, our formula volume must be in terms of R. dv dt already stated in the question, so we start from volume formula in terms of what? In terms of R. So spherical volume, it will be 4 over 3 pi r cube. Therefore, you can find dv dr, power move to the front, power minus 1. So dr dv as you inverse, denominator go to numerator, numerator go to denominator. Then our last step is substitute here. And lastly, substitute our value of R. So here we have our answer, or you want to put in decimal also can. Then we move on to the second part, B, for the rate of change of its surface. So ds dt. Surface area only can relate to R, then we time with dr dt or dr dv time with dv dt. Since our dr dt we don't have the formula, so we put back the original formula with ds dr, dr dv, and dv dt. So start from the surface area formula. Surface area for a sphere, it will be equal to 4 pi r squared. So when you ds dr, we get 8 pi r. Therefore, we substitute into our chain rule. Here we have 8 pi r. Then dr dv is 1 over 4 pi r squared. dv dt is 250. As you can see, pi can be cancelled, r can be cancelled, so it will be 8 times 250 over 4 times r. r is 15. So simplify, we get this cm squared per second. You want to put in decimal also can, but we recommend you to put in fraction.